Hello, this is Mr. McCullum, and this will be your lesson for January 26, 2011. Today we're going to be talking a little bit of something called Newton's Laws of Motion. And as it turns out, there's going to be three of them. But to get us started today, I want to make sure everybody is effectively engaged in the ways of Newton. But if you're not familiar with the laws of Newton, maybe you're familiar with some of the aspects of how we use Newton laws around us. For example, if I were to push this heavy bookshelf, it moves a little bit, but it gives resistance. As you can see, it pushes back on me as much as I push back on it, and then it returns to its stable position. Okay? That would be technically two of Newton's laws. The first one, since I don't really have an example for the other one, is, now let me just give you the book definition, okay? It says an object at rest remains at rest, and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. So effectively what this is saying is the bookshelf stays still. Gravity is pulling it and keeping it anchored to the floor here, and my pushing on it unbalances it in this direction, and the bookshelf returns back to its position once more. Okay? Now, let's move on to Newton's second law. It says the acceleration of an object depends on the mass of the object and the amount of force applied. So, let's build on that. All right? We're going to use a little toy car here, and we're going to slide it across two surfaces. Okay? Now the one is going to be a smooth horizontal surface. And here we have our little toy Elmo car. And let's go ahead and give him a slide. Now, the way it looks on the bottom here, it has two blue wheels and a little stoppy part right here. So, but this is really only a toy car for some reason that I seem to own in my house. Alright, so let's bring this forward here. And let's slide Elmo on the carpet. Do we notice anything different? Is Elmo going as far? And this little rudder part on the back makes it even harder for him to go. Alright. Let's look at the floor one again, just so you can see that again. Okay, and finally, let's think of one last application. Elmo versus the wall. Elmo seemed to slide gracefully before, but what's happening? Why is Elmo stopping when he hits the wall? What is it about the wall that causes Elmo to stop? We might think of this innately or intuitively, but what is it about the wall that causes Elmo to stop? Think about that one real hard. All right, let's look at Newton's third law. It says whenever one object exerts a force on a second object, the second object exerts an equal or opposite force on the first. So, that's actually Newton's third law in motion. Every time Elmo hits the wall, there is a force that the car hits the wall with. And an equal force bounces Elmo back to a position that is equal in force of essentially stopping power. That puts Elmo back to where he would be. That is, if Elmo is accelerating forward and he hits the wall, he's going to bounce off and land at a place equidistant to that of the energy he exerted when he impacted the wall. Okay, so now let's think about Newton's second law in terms of comparing two objects. Let's say we have the Elmo here, which is a light, more gently smoothing object, versus a very large shoe that's bulkier, heavier, and obviously weighs more. So remember what we said. Newton's second law is a function of mass times acceleration, right? So the greater the mass, the greater the friction that the object is going to pick up and ultimately get stopped by, if you will, whenever we roll these objects across the floor. So let's start the two objects going in one direction, or going in the same direction. Let's do the same direction. And let's accelerate them forward. What do we see happening? The Elmo car went further each time, and the shoe stopped very quickly when being scooted across the smooth floor. Let's superimpose this idea with the carpet, as we did the first time. On our marks, get set, launch. Notice that both objects behave in the same exact way, only they're stopped even more. What is it about the carpet that causes both objects to stop propelling forward? And what could we do to make the shoe glide better in both cases? Think about that one. And last but not least, you're going to be receiving a directed reading assignment. In this directed reading assignment, you'll be using the book to discover the answers to the questions located on the worksheet. If you are a standard ed or a gifted ed student, you will receive the directed reading A assessment. If you are a student on an IEP, you'll be receiving the directed reading B assignment. Please make this consideration whenever you decide to download this activity from the web to make sure you pick the right one. Thanks.